Hello everyone, welcome to Learn Overflow. In this video, we will discuss about today's LeetCode problem, that is the Fibonacci number. Obviously, this is an easy level question, and but we'll try to understand how we can approach this question in like top-down DP and bottom-up DP. Like we'll go ahead with DP. We can. I will discuss about the normal way, like the recursive way to find the DP, and also I'll discuss the other way, that is simple iterative way to find the DP. Okay, like not DP, but find the Fibonacci numbers. So let's see what exactly the question is telling us and how we can how we should proceed to find a solution to this kind of question. Let's understand that. So first it says the Fibonacci numbers are commonly denoted by f of n. Form a sequence called the Fibonacci sequence. This is the Fibonacci sequence. I will show you in a moment. Such that each number is a sum of two preceding ones. A sum of two preceding ones. Okay, starting from 0 and 1. That is, f of 0 is 0, f of 1 is 1, and then following numbers will be following this pattern. So it's more like you have this first number is 0 and second number is 1. Okay, and following we'll go ahead with sum of this two. 0 plus 1 is 1. Okay, 1 plus 1 is 2. So 2 plus 1 is 3. Okay, 3 plus 2 is 5. Then 5 plus 3 is 8. Okay, and then 8 plus 5 is 13. So this is the pattern. It keeps on going, and like we need to sum up the last two, like two previous values to find out the next value of it. Okay, now how can we go ahead to finding a solution like this? Okay, let's try to see the examples once. So it says when n is 2, the answer is 1. How? N is 2, that means this is 0, 1, and 2. So we are returning this particular value. Okay, that's the number 2, like 0, 1, and 2. And then when n is 3, we are returning 2. That means 0, 1, 2, and then that's the third position we have, and third position's value is 2, right? And thus we are returning what? 2. That's the output we have. Okay, f of 3 is f of 2 plus f of 1. f of 2 plus f of 1 is this particular 3. So we found our answer. Okay, and following when n is 4, we are return 3. That is, you can see 0, 1, 2, 3, and 4. The fourth position value in our all the values we wrote is like 3. So that's what we are returning over here. So this is the idea behind such a question. Like that's what the question is talking about. Okay, so if we have given 4, so that means basically means when you are trying to find the fourth value is basically sum of the third value, like f of 3, not like the position value. Okay, f of 3 plus f of 2. Fine, that's the value. So now each case f of 3 is what we need to again see. F of 3 is again f of 2 plus f of 1, right? F of 3 is basically f of 2 plus f of 1. Fine, that's what we have. And also this f of 2, and then f of 2 is what? F of 2 is f of 1 plus f of 0. So basically f of 1 plus f of 0. So that's the question we have over here. Okay, so that way we'll keep on breaking the numbers into the lowest form, and this f of 0 is 0, f of 1 is 1, f of 1 is 1, and then f of 2 is f of 1 plus f of 0 again, so 1 plus 0. Okay, so see how what the value is, 1, 1, and 1, and thus we are returning 3. So this is the exact question that they are asking us. Okay, what we need to, we will get a value and we need to break it till its lowest form, and then we will find out a solution to the particular value. So what are the ways we can find a value to that? The first way can be you just get a number. Okay, like the way the num n is given to us. Okay, given is n, like we can say like given n. We'll look at the answer, but let's discuss like what can be the solution ways for that. So first thing is, if n is less than 1, there's no point, right? If n is less than equal to 1, if it's over here, then we should like if the value lies this side, then we should more or less return the value itself, right? There's no point calculating anything further. If n is like greater than 1, now how we can go ahead, we can keep on changing values. Like we took a variable a equal to say 0, and we took a b equal to 1, and then we can run a like while loop, like while. Okay, and within the while loop we can go ahead like n minus greater than 1. So that's the idea we have. Greater than 1 being greater than 1, and within that we will find the sum of like a plus b being the sum. Okay, say a value is a plus b, and then we'll do like a equal to b, and then b equal to s. That's the while loop we will have. And after the all the till n becomes 0 or n becomes 1, we'll ultimately find out what's the value we have. Okay, that's the idea we have over here, and that's like the, and ultimately we will return b. Okay, I just wrote RET, so just take it as return b. So this is an iterative kind of solution we have. Okay, we are running through a while loop and taking the number of steps and continuing with the sum, like sum of a plus b, and ultimately returning the value of v, since b is ultimately storing the sum over here. So that's an iterative kind of solution you can think of. This solution is like I think this is the best solution if we take the both the cases, like both time complexity and space complexity in count. So in this, the space complexity is order of 1, and time complexity, you can see it's running only a while loop of n elements. So that's like order of n, right? So this is the value we have. So that's the order of n being the time complexity, and the other being the space complexity being order of 1. So that's an normal iterative process, and it's pretty fast. It's not a slow one. Okay. The other kind of solution you can think of is, let me series this off. Uh, The other kind of solution you can think of is like a recursive solution. So you are getting a fib of n, that's the number you're getting. So you just have a first check that if n is less than equal to 1, you return it. That's the initial check. And then you will keep on doing like in the else case, you will do like fib of n minus 1. Okay, that's 1. So fib of n minus 1 plus fib of n minus 2. Okay, I'm sorry for this writing. So there's a thing n minus 1 and n minus 2. You will keep on adding them, and like you will go into the recursion loop. Okay, so you will return this. Okay, so that's the idea. If like within this loop, just like within the function, just give a check that if n is less than equal to 1, return the value. Else return f of n minus 1 plus f of n minus 2. So that's the check you will have, and you will keep on checking that again and again, and you will keep on finding a value. But think of something like that. Say if we're finding a fib of 4, okay, like a value n being 4, then you got fib of 3 plus fib of 2. Then you broke fib of 3 in fib of 2 plus fib of 1. Okay, fib of 2 plus fib of 1, you broke them into that. And once you break them into fib of 2 and fib of 1, see, you again found like break fib of 2 into fib of 1 and fib of 0. Okay, you found a sum of fib of 3, and going back, you actually calculated a sum of fib of 3, and then you moved into fib of 2 again, and again found like fib of 1 and fib of 0, and then found a sum and return back. But don't you think this a fib of 2, that is this particular part we have over here, is just a repeat of this particular part, right? So if that is a repetition is happening, then we can think of some kind of DP or dynamic programming solution, because that's how we stop this repetition and remember our values from previous calculations. Okay, that's what DP is all about. Say the number is much bigger. Say you are going for to find something like fib of 10. Okay, so fib of 10 is fib of 9, like not 0, 10. So it will be 9 plus 8, right? So 9 plus 8, 9 will contain 8 plus 7, right? And 8 will contain, you are going to calculate an 8 over here, a large 2D graph, like a binary tree kind of will be formed over here. Like if you just see all the iterations, then a kind of a binary tree will be formed. And again, that particular tree or calculation we need to do over this 8, right? But again, if we break 8, there will be 7 plus 6, right? This 7 and this 7 will be repeated. So when you're seeing the repetition is there, then we can think of a better solution. That's a dynamic programming approach to find out how we can remember them. Okay. But before I move into the DP approach, let's discuss the time complexity of this. So you can see, like on each level, we are breaking down into 2 different operations. So that would be more like T of n equal to T of n minus 1 plus n minus 2, right? So that becomes an exponential type complexity, that is order of 2 to the power n, and that's a pretty huge complexity if you have a larger value, like n being a bit larger. So that's 2 to the power n, and space complexity is obviously order of n. How order of n? We are just like the recursive call stack function is being called, and that's the like n times the function will be called. So that's more or less the recursive approach we have over here. Okay. Now let's move into the DP approach over here. The DP approach will be we will have an kind of an we will remember the values and then we will uh, keep track of all the values we have over here. Okay. So this is the DP approach I wrote already for you. So this approach is more or less like a bottom-up approach. Like in DP, there can be two approaches. Okay, let me explain them in details as well. So what can the two approach of a DP? So the one is, as we say, the bottom-up approach, and the other is what we say the top-down approach. Okay, so bottom-up approach is more like say you need to find a value of n, right? So we are given an n, you need to find a value of it. So how will you go ahead with it? You'll start from 0 and 1. Okay, the same way we were doing in our normal iterative way or the normal iterative way what we were doing. So that's the one. We started with 0 and 1, and we keep calculating, the series, till we reach an answer like that particular value and return that final value. So you started from the bottom and went up to the final answer. That's a bottom up approach. Okay. The other approach we have is like the top down approach. That's more like you started from this position value. Okay. And keep on breaking down till you get a lower base case. You got a base case. That's like you started from the top. You went into the deep, and then you found a base case over here. And once you found a base case, you will simply reverse back to our final answer, and then we'll just return our answer like the one way we were doing in our recursive approach. We started with the main value. We started breaking it into two recursive function calls, and we started to calculate the value. Right. So that was the idea behind the top-down approach. So both top-down and bottom-up is like we can do like what we are doing in a recursive approach. We are just calling the functions. But what if we keep a check that if the value at that position in the additional array or the or a particular array we have, okay, if the more or less the fifth cache you can say. So once we have a value for that particular element, it can be like we got a value. Okay, now what can be done? We can store the value in our position, and once we value repeated, we'll simply return that value. Else we will go ahead with finding its value. So that's the idea behind the top down approach. And the one I have over here is the bottom up approach. That is the one I love the most. And what we are doing over here, we are simply taking if n is less than 2. N is less than 2 is like those 0 and 1, those two values are there. So we'll say return n, fine. And then we took a Fibonacci array, and then we stored our initial two values like 0 and 1. Those are the initial two values. And then we started from 2 till n. That is, we started from our lower values, like the loop is going up. Okay. We started from 2 till n, and then we went ahead with we found that like fib of I is fib of I minus 1 plus I minus 2. So it's not a function call. See, we are not calling the fib function over here. Rather, we are just calling the array over here, right? Fib array that we stored, like that we created. So we're just calling the fib array, and we keep on calling the last two values. Like initial case 0 plus 1, fib of 2 will be 0 plus 1 equal to 1. So that's where we keep on calculating the value within the loop. And ultimately on fib of n, we just return our value. Okay, remember something like when it says n, our initial stuff is like we create an array size of n, but while using DP, it's usually we'll find more or less on every case we need to create a value of n plus 1. Why? Because the array starts from 0 and we need n values, not the 0th value. Okay, so the nth value, in the sense like we need to go for the next value, that is n plus 1. So that's the idea behind like we should keep in mind, but it depends on case to case. We should remember how, when, and where we need. So we just need to look into that whether we need or not, and we'll find out based on that. So that's the question we have over here. Okay, so I hope this is understandable. I will let's discuss the time complexity of this particular approach we have over here. Okay, the particular approach, this particular approach time complexity will be more or less like if we just think, we are using only a single loop, and that single loop is running from like all the n values, right? That the single loop is going through. The loop I'm calling is like this, and this is order of n. Like, and other than order of n, all other operations we have in our particular program is like all are order of 1. So the time complexity will be order of n, fine. And the other one we can have is the space complexity. The space complexity you can see, you just created an array of size n plus 1, right? And any other spaces you took? No. So that's the only an array being created order of n. So that's an order of n being the space complexity, and this is the time complexity. So that's the complexity we have over here. So thank you all for watching this video. I hope I can make you understand how you can solve the question like this. And just for your clarity, I will just run the code once, and you will understand how this particular is working. So that's all for this video, guys. I hope you are able to understand this program. And if you have any doubts, make sure to comment down your questions in the comments below. I will be happy to help you out as well. Thank you all for watching this video. Hope to see you soon in my next video as well.